All right, we're going to begin factoring this lesson. All right, so chapter P, section 4 is going to be all about factoring. We're going to start with some techniques, and your quiz is going to be on not all of the techniques, but it'll be some of them, whatever we go over in class. We're going to start with the GCF. So if you remember factoring a GCF, we're looking in each of our terms, and we're finding the greatest common factor of each of them. So for example, something like 6 and 4, I'm looking at the number with the number. Well, 6 I can write as 2 times 3. 4 I can write as 2 times 2. They both share a factor of 2. I can take that out. And then x to the third, remember that's the same as x times x times x. So I can take out 1x with 1x and then take out just 1x on the outside. And then whatever you get left over is going to be whatever you get when you divide by the GCF. So it's going to be a 3x squared minus 2 left over in parentheses. All right, so something like this one, number 1. What I like to do if the first term is negative and it's already in standard form, I like to pull the negative out with it. So I would start by taking out negative. Between 4, 12, and 16, we can take out a 4. All right, so far I'm dividing by negative 4. And then I can't take out any x's, so negative 4 is my GCF. Dividing everything by negative 4, you're left with an x squared minus 3x plus 4. And that's as far as you can go with this problem. All right, looking at the next one. It looks like between 3, 6, and 9, I can take out a 3. All right, so let's start there, divide everything by 3. And then it looks like between x to the third, x squared, and x, I can take out 1x. Again, x to the third is the same as x times x times x. X squared is x times x. And then I can take out 1x from each of these terms. So I can take out a 3. Let me erase that. It would be a 3x. And then divide everything by 3x. Should get you x squared minus 2x plus 3. All right. And we can look at the next one. And I can check, right, between number, and the number. I can take out a 5, between 5, 25, and 30. Between x squared, x, and x, I can take out 1x. Between y squared, and y, I can take out 1y. So I'm going to divide everything by 5xy. And then you're left with just an x in the first term, a 5y in the next, and then a minus 6 in the last. All right. And then in this next one, it looks like we have something a little bit different. Keep in mind, though, a factor is just something that's being multiplied with something else to get an answer. So keep in mind, this x minus 2 times 2x and this x minus 2 times 3, these are all factors. The one that they share in common is the x minus 2. If you take out an x minus 2, you're left with a 2x, a plus, and a 3. And then that's your final answer. All right. So using that same idea, we're going to factor by grouping. So if a polynomial has 4 terms, you're going to factor by grouping. So you're going to pair 2 terms out of the 4, factor the GCF until the parentheses match, and you factor out the matching parentheses and group together the remaining factors. All right, so a lot of words, but for example, let me just show you with this one. There's 4 terms here. So I'm going to group the first 2, group the second 2. Between our first 2 factors, between x to the third and minus 2x squared, I can take out an x squared. And I'm left with an x minus 2. Between 3x and 6, I can take out a 3. And then you're left with an x minus 2 there. Notice that x minus 2 and x minus 2 match. And then notice that x squared plus 3 are left over. So then whatever's left over is going to become its own set of parentheses. Whatever matches just shows up once in your final answer. So your final answer would look something like that. All right, so here, number 5, I have 4 terms I can factor by grouping. Group the first 2, group the second 2. So in our first group between x to the third and x squared, I can take out 2 x's, so x squared, and then you're left with an x plus 1. Right? Again, just divide everything by x squared. But in our next group, I can take out a negative 5. 5 is also a common factor, but keep in mind I want the parentheses to match. When I divide everything by negative 5, the x plus 1 matches. And so that I can pull out as a common factor, and then you're left with an x squared minus 5 in the other parentheses. All right, same thing with the next one. Group the first 2, group the second 2. and I can take out an x squared from our first group. I'm left with an x plus 5. I can take out a negative 5 from the next group, and I'm also left with an x plus 5. These parentheses match. I can write it once. The x squared and the minus 5 are left over. That's going to be its own set of parentheses, and this would be my final answer. All right, the next problem. What I like to do, you don't have to do it for this problem, it works either way, but just to get into the habit of writing your polynomials in standard form, just because down the line it's easier to factor when your polynomials are in standard form, so I'm going to write it in standard form, right? Decreasing exponent order. Once you do this, you can factor by grouping. Group the first two, group the second two. GCF of our first group, between 8 and 12, I can take out a 4. Between x to the 5th and x to the 3rd, I can take out an x to the 3rd. And I'm left with a 2x squared plus 3. And in our next group, I can take out a negative 3, right? Dividing everything by negative 3. We're left with a 2x squared plus 3. Our parentheses match, so that's going to show up once. And then 4x to the 3rd minus 3 is going to be its own set of parentheses, right? Those are the GCFs that we took out. All right, last one on this page. Again, 4 terms. It's already in standard form. I'm going to group the first two, group the second two. I can take out an x squared from the first group. I'm left with the 3x plus 1. In my next group, I can take out a negative 5, and I'm also left with the 3x plus 1. So I get an x squared minus 5 in the first group, a 3x plus 1 in the second group. Right, the 3x plus 1 matched. X squared minus 5 became its own set of parentheses. All right, lastly, this is just a combination of both factoring methods, right? So what you want to do first always is check if there's a GCF. All right, maybe on your quiz you're not going to have to do this for every single problem, but just to get into the habit down the line for your test, you might have to factor a couple times in one problem. All right, so let's start with number 9. Notice that between all of these terms, I can take out a 3. So I'm going to start by taking out that 3, and then I get another polynomial left over on the inside. All right, so something like that. All right, and now that I took out a GCF of 3, notice that I have 4 terms on the inside of my parentheses that I can factor by grouping. So I can group the first two, group the second two. And then from the first group, I can take out, whoa, what happened? Okay, I can take out an x squared, and I'm left with an x plus 1. I can take out a negative 10 from the next group, and I'm left with an x plus 1. All right, so then I still have that 3 left over on the outside. Inside of my parentheses, the x plus 1 matches. And then x squared minus 10 becomes its own set of parentheses. And then don't forget about the GCF of 3 that we took out. So this would be your final answer. Same idea, just with one extra step in the beginning. All right, so I'll try the same thing with the next one. In our next group, I can take out between all of these terms, I can take out a 2. When you take out a 2, you're left with x to the 3rd plus 3x squared minus 2x minus 6. And then once again, I can group the first 2 and then group the second 2. GCF of that first group is going to be an x squared. I'm left with an x plus 3. GCF of that second group is going to be a negative 2 I can take out, and then I'm left with an x plus 3. And then I still have that 2 left over on the outside. All right. And then on the inside, x plus 3 matches. X squared minus 2 is left over. And then I have that 2 left over on the outside as the common factor. So your answer would look something like this. All right. This next one, again, GCF between these, I can take out 2 x's. So it's going to be an x squared. I'm left with an x to the 3rd minus 7x squared minus x plus 7. And then again, group the first 2, group the second 2. Between those first 2, I can take out an x squared. I'm left with an x minus 7. In our next group, I can take out a negative 1. And then I'm left with an x minus 7. All right, so a GCF of 1 is also a valid answer, but keep in mind you want the parentheses to match. So I would take out whatever gets the parentheses to match, and that would be a negative 1. And then I get an x squared minus 1 with our GCFs, an x minus 7 left over, and then the x squared on the outside. Now, you'll learn from our next lesson that this x squared minus 1 actually becomes x plus 1x minus 1. This is a difference of perfect squares, so this would actually be the final answer. All right. I'm sure by now, at this point in time, I had already taught the lesson, so hopefully that part makes a little more sense than it did when I first taught it. All right, but that's what happens there. All right, so when you factor, make sure you factor completely. And then last one, it looks like in these terms there's no GCF, so I would just jump straight to grouping. Group the first two, group the second two. In our first group, I could take out a 5t to the third, and I'm left with a t plus 4. In my next group, I can take out a 3, and I'm left with a t plus 4. 5t to the third plus 3 is what's left over, and t plus 4 is what matched. So we get that as our final answer. All right, and that's factoring by GCF and grouping. The next lesson, which is the last one before your quiz, is going to be on difference of squares and perfect square trinomials.